Your goal after watching this video is to know how to find the area of a parallelogram. And probably to know what a parallelogram is too, if you don't already. Alright, so starting off, parallel lines. What are parallel lines? I'm going to draw a few examples for you, and you can draw these in your paper as well. So parallel lines are two lines, or it could be more lines, that if they keep on going forever and ever, so if this line keeps going, and this line keeps going, and this line keeps going, that line keeps going, they're never going to cross. They're never going to intersect. They'll never get closer together. So that's one set of parallel lines. I could draw another set over here. Alright, so I need another line that will never intersect this one. It will never cross it. So those two lines could keep going forever. They're not going to get closer together to each other. They're not going to intersect. I could draw another line that's parallel. So this could be a set of three parallel lines. So there we have our examples of parallel lines. A parallelogram then is a polygon with exactly two sets of parallel lines. Feel free to copy that down if you need to. A polygon or a shape with exactly two sets of parallel lines. A few examples of parallelograms are squares. This line right here is parallel to this line right here, so there's one set of parallel lines. This line right here is parallel to this line right here, so every square is a parallelogram. Rectangles are also parallelograms because we have exactly two sets of parallel lines. So the top line is parallel to the base line, and the widths are parallel. So that's two sets of parallel lines. Now, squares and rectangles are not the only thing. We could have something that looks like this, without perfect right angles. So that is a parallelogram because this line right here is parallel to this line right here. And this line right here is parallel to this line right here. The reason that that is not a rectangle is because its angles are not 90 degrees. And parallelograms like this are what we will be talking about today, how to find the area of one of those. Okay, so to find the area, and a lot of times in math when we talk about area, we use capital A to say this is the area. To find the area of a parallelogram, you take the product of its base, all right, which is oftentimes represented by the letter B, and its height. Height, which is oftentimes represented by the letter H. Remember, product means multiply. So below, they've abbreviated that formula to find the area of a parallelogram. You multiply base times height. Okay, the base, or the distance along the bottom, times the height. Notice that we are not looking at this slanted line. All right, that is not our height. That's not telling us how high it is. We're looking at our height, so that means the distance from the highest point of the parallelogram straight down in a right angle that meets our base. Okay, find the area of each parallelogram. So first thing I'm going to do, and first thing I want you to do, is write your formula. Area of a parallelogram equals BH, base times height. If you want to write times in there, you can. All right, so we're looking for the area. This is the thing we don't know, is area. But we do know the base of this parallelogram. All right, so I'm going to write area equals base, which is 12 meters, times height. So my height, my distance from the very top point of my parallelogram straight down to the base, meeting it at a right angle, is 14 meters. Okay, so to find the area of this parallelogram, the amount of surface it covers, I take 12 times 14, base times height. I know what 12 times 14 is. Do you know what 12 times 14 is? Write your answer. Okay, what number is that? Then notice that I'm also taking meters by meters, meters times meters. And any time I take something times itself, I can write it to the second power. So like 2 times 2, I can write it as 2 to the second power. 3 times 3, I can write it as 3 to the third power. 4 times 4, I can write it as 4 to the second power. So m times m, I can write as m to the second power. So your answer is going to be whatever 12 times 14 is. You should calculate that on your own. 12 times 14, that goes right here. and then meters squared is our area of that first parallelogram. All right, our second parallelogram in part B. Again, parallelogram because it has two parallel sides, all right? And here's the second set of parallel sides. So I'm going to get rid of that so we can see a little bit better what we're doing. Okay, we want to find the area. I know to find area, we take the base times the height. My area is unknown. I'll leave my letter A. The base of this parallelogram. All right, the base. Well, right now, the base is not at the bottom, okay? But if we flipped this parallelogram, so it will look like this, all right, then this would be on the bottom, 8.5. So our base length is 8.5 feet. So I'm going to take 8.5 feet times my height, all right? And my height of this parallelogram then would be the distance from the top straight line right angle to the base. So my height of this parallelogram would be 4 feet. So I'm going to take 8.5 times 4 feet. All right? I suspect that you on your own can figure out what 8.5 times 4 is. And if you need to use a calculator for that, that's fine, 8.5 times 4. But I'm going to remind you that we're also taking feet times feet. And anything times itself like that, we can write with an exponent of 2. So our answer is going to be whatever 8.5 or 8.5 times 4 is, and we're going to label it feet squared. Okay. Find the area of a parallelogram on a grid. So we have been given, we're not doing this one, I'm not sure why that's there. Secretary messed up. All right, find the area of the parallelogram. Count grid lines to find the dimensions. Okay, so by looking at this parallelogram right here, okay, we need to find its area. So we're going to find first its base. All right, and in this case, they're using the shorter end as the base, which is fine. All right, you can pick which side is going to be your base. That's fine. The reason they're not using this as the base is because it's harder to count the grid lines. Right, that one doesn't line up perfectly with grid lines. It slices through them diagonally. So we can see here though that our base is 2 squares. So 2 units. We don't know if each of those grid lines is a centimeter or a meter or what it is. Then we need to find our height of the parallelogram. Okay, so we're going to go to our highest point from the base. So the highest we go is way up here. And we're going to say, okay, what is the distance from that line from the height perpendicular to the base? So here's the highest point of our parallelogram. Here's the lowest point of our parallelogram. How far is that? 1, 2, 3, 4, 5 units. We don't know again if it's centimeters, inches, or what how big those grid marks are. Okay, so I'm going to take area equals base times height. So my area equals my base of 2 units times my height of 5 units. So my area is going to be 2 times 5, which is 10 units times units, which is units squared, or square units. So there's my area of that parallelogram.